Okay, welcome back everybody. This is lesson 4, where we're going to talk about solving some of these quadratic equations using a graph. So we've done a little bit of the algebraic stuff, but graphs can sometimes tell us a lot as well. It's helpful to see what these equations look like in a graphical form, and on our calculators there's a lot of features that we can use to help us solve some of the same things where we could do them algebraically as well. So this video is going to show you all those calculator buttons, how they're going to work, some of the things you have to keep in mind when you graph them. So this is a good video to keep coming back to if you're getting ready for an exam, a quiz, something like that, where you need a little bit of help with those calculator buttons. So again, a quadratic function is an equation of degree 2, and all that really means when you see something that's in degree 2, it just means you've got one of the variables has an exponent of 2. Okay, the highest degree or the highest exponent in that expression is 2. So a quadratic equation is going to have an equal sign. Now we sometimes write them in terms of y, and another way you can see a quadratic function be represented is a function in terms of x is equal to whatever the expression happens to be. So here x is just the input, y or f of x is our output, the value we get after we actually solve it. So a quadratic equation then is just something with an equal sign, and it's actually equal to a specified value or expression. It actually has something to be equivalent to. Now quadratic equations can be rewritten so that they're equal to 0, and this is going to be helpful for us in terms of solving for x. So if I ever want to solve for the actual values of x, the x-intercepts, it's going to be helpful if it's equal to 0, and it's preferred that our a value is positive. It doesn't need to be, but it makes it a little bit easier if it is. Now to solve one of these, right, we're really determining the roots, which are the x values that make the left and right sides of the equation equal to each other. Okay, this is the key. So if you have two things on your equals, or if you have two things, one of which on either side of your equal sign, we're trying to find the x values that make them equal. Or if my equation is equal to 0, we're looking for the x-intercepts, and on our calculator they are straight up called the zeros. So if my equation is equal to 0, I'm looking for zeros. If it's equal to two expressions, so left side and right side, we're looking for where they intersect. And we'll do both on this calculator here to show you where all the buttons are, how the things are going to work. So we're going to do all of these graphically. So this next page here, which again you'll have all the resources and the links underneath this video here, but they will tell you all the buttons you need to press that correspond to their given calculator function. And again, you can see in all the steps we have to press second trace to get to everything, right? It'll be our calculate menu. So up above trace, and I can show you what it looks like. If you press second trace, there's the calculate menu. And we're only going to use the options from 1 to 5. 6 and 7 are going to be reserved for calculus. Okay. So 1 through 5 is all we care about, and all 5 listed on this page telling you what buttons to press and what it should look like. So again, a very helpful page to come back to. So example 1, graphically solve them if possible and round those roots to the nearest 10th if necessary. So if I look at number 1 here, I've got x squared plus 5x plus 6. So the first thing I'm going to do is hit y equals on my calculator, and I'm just going to graph it. So x squared plus 5x plus 6. Now this is equal to 0 on here, so really the only part I'm graphing is the left side of that equation, and I'm putting it under y1. Now really you can put it under any of these, it doesn't matter, but when you press graph, ideally we can see what our parabola looks like. So here's our quadratic equation. Now again, I'm equal to 0. Okay, so here's just the side notes. I'm equal to 0. So on my calculator, we are going to find the zeros. And really what that means is we're going to look for the x-intercepts, because those are going to be the values of x. If I were to put them back into the equation, will make this true, right? It'll make it equal to 0. Now it's hard to tell exactly where my x-intercepts are here, so we're going to zoom in a little bit. Now, if I press window, my standard window screen on the calculator is a 10 by 10 square. Now, if I care about the x-intercepts and it goes from negative 10 to 10, it's pretty zoomed out, and I can't really tell where my x-intercepts are going to be exactly. So I'm going to zoom in a little bit, and maybe let's make this negative 5 to 5. And you can see a little bit easier that, well, there's going to be two places where they're going to cross. And I know those two places aren't anywhere from 0 to 5, so we can zoom in a little more and make my minimum value of x. So leave it as negative 5, but the maximum value, let's make it 0. So essentially, we're just going to cut off the right side of this graph, and I'm only going to see it, you know, the part that I actually care about. But again, I know there's two, but it looks like they all blend together into one point. It's pretty zoomed out still, but now it's zoomed out in the y direction. So let's change our window for settings for y, and maybe we'll make it, you know, negative 5 to 5 instead of negative 10 to 10. We'll zoom in, and now I can see a little better that, you know, it does go dip underneath that x-axis. So maybe let's make this a little bit smaller even. Let's go negative 2 to 2, and then hit graph. Okay, so that looks a little bit better. So I can clearly see that there are two places where it's going to cross that x-axis. And if I just count the tick marks, I know it's going to be at negative 2 and negative 3, right? I can see it on here, but sometimes they won't line up perfectly, so I don't really want to count just the tick marks on the calculator. Whoops. So what we can do is we can press second trace to bring us up to that calculate menu, and option number 2 says 0. And if you press it, well, your calculator screen looks a little strange now. So it tells you, you know, left bound, and there's a question mark. Your equation's up in the top. Now, when it says left boundary, you're setting the leftmost value of x where your calculator is going to search between. And my cursor tracks the graph. So in terms of setting the x value boundary, I want it to be the leftmost boundary. And we have to do this 2 separate times, one for each of those x-intercepts. So right now we're going to do the left one. So my cursor is on the left side of it in terms of its x value, right? It's more left than the actual intercept is. So I'm going to press enter, and you'll see a little triangle come up. So that triangle sets the boundary that the calculator will search between. And you'll notice when I hit enter there, the question changed, and now it says right boundary. So we're going to move that cursor just far enough so that it is now on the right side of the x-intercept we are finding. I can't go all the way to the other side of the graph because then both intercepts are going to be in between my triangles. So if I hit enter, here are my 2 triangles. Notice that they're pointing together and they're pointing towards the x-intercept that I'm going to find. If you have 2 x-intercepts in between the triangles, your calculator's not going to know which one to tell you. It just guesses, right? Which is why the question just says guess. So by us telling us and defining for the calculator that there's only going to be 1 x-intercept in between the 2 triangles, it is going to tell me that one. It doesn't have another choice. So when I press enter for a 3rd time, it will tell me that the 0, or the x-intercept, is negative 3. So x equals negative 3. I found one solution to this equation. And if I were to plug this back into that equation, and you know, I'll test it out to show you what I mean, well, negative 3 squared plus 5 multiplied with negative 3 plus 6 should equal 0. So 9 minus 15 plus 6 equals 0, which it does. So this is what we're actually finding, the value of x to make the original equation 0. Unfortunately, I have to do this twice every time because in this case I have 2 separate x-intercepts. So again, I'm going to deal with the right one now. So my cursor has to be on the right side of that intercept, so hit enter. Move the cursor, so now it is on the, oh, did I say right before? Sorry, I meant the left side of that first intercept. And now it's the right boundary question, so the right side of that intercept. In between the triangles that are pointing together, there is only 1 x-intercept, so it will tell me that one, and it is at negative 2. So there is the other one. what we would have done previously is just factored this, right? I can factor this original expression, and I'm going to know that, well, it's x plus 3 and x plus 2 are going to be my two factors, right? Because they are the two numbers that multiply to 6 but add to 5. So actually solving it for the zeros then, well, x has to be -3 or x has to be -2, right? Just like how we would have done it previously. But using my calculator is quite nice because sometimes, you know, the numbers aren't right. Sometimes I can't factor things, which we've seen before. So there are a few here, which again, I won't graph all of them. I'm just going to pick and choose a couple. So let's do, you know, maybe let's do D here. Because, you know, looking at it, it's a little bit more work to factor. Like I could try to find two numbers that multiply to 10 but add to 5, but, you know, I might not be able to. So let's, you know, get our equation out of here. We'll put in the new one. So hit y equals, clear out whatever you had. So 2x squared minus 5x plus 5. Again, it's equal to 0, so I know I'm looking for the zeros on my calculator. Now when I press graph, just remember we changed what this screen looks like. If you ever want to reset it back to normal, press zoom 6. Zoom 6 will turn it back into the standard 10 by 10 window. So here's my graph. All right, now something to think about here. If we said that, you know, if my equation's equal to 0, I need to find the zeros, which really means the x-intercepts. Now if I look at this graph, it does not cross the x-axis anywhere, so there are none. There are no x-intercepts, which means there is no solution to this, which is totally acceptable. Sometimes, you know, graphs don't cross the x-axis, which is possible. So here, I don't even have any work to do. There's no answer, right? There's no x-intercepts, there's no solution, there's no zeros, nothing to do, which is totally fine. So we're done with that one. Let's take a look at E, because now it's not equal to 0. So let's think about this for a second. You know, we did the equal to 0 case, but now it's not equal to 0. So the other way that we can approach this is take the left side of the equation and graph it under y1, and, you know, the right side of this equation, why can I not draw this right now? There we go. And make it equal to y2. Now if I set them equal, you know, in different parts of this, so let's graph it first. X squared plus 4x minus 3. Make y2 or y3, it doesn't matter, just some other one, equal to 5. If I've got two expressions here, so we really are looking for where the left side is equal to the right side. In other words, we're looking for where these two expressions are going to intersect. So it's a new function on our calculator. So I'm going to press graph just to show you what it looks like. So this is the left side, my quadratic, my parabolic shape, my parabola. y2 is my horizontal line. It's 5. Now there's two places where these cross. And when I find their intersection point, I'm looking for the x value. So the way this works on a calculator is when you press second trace to open up that calculate menu, you're going to see option 5 says intersect. So you can scroll down to 5 and press enter. And again, your calculator is going to ask you some questions. The first thing it will ask you is it will say first curve. And a curve in math just means, you know, a line, an equation, some graph, right? It just means curve. Now the way that this works is you're going to need to put your cursor close to one intersection point. Now, it can be exactly on it, it could be just close to it, it doesn't matter, as long as it's closer to one of them than the other. And if it is, y1 is highlighted by defaults. Excuse me. Y1 is highlighted by default, so that's what we're going to designate as the first curve. Now when you press enter, after telling your calculator that's the first curve, it will change. The question will now say second curve, and y2 will appear in the top corner. It'll switch from y1 to y2. And you'll see the cursor now is on your horizontal line, which you can move around. And again, just make sure the cursor is close to that intersection point, which it is, so just hit enter again. and then guess. So your calculator is going to take the two lines close to that point and tell you where they cross once you hit enter for a third time. So here's my intersection point. So I know now that the x value is, it says to the nearest tenth, so negative 5.5. But there are two places where this crosses, so I have to do this again a second time. So second trace, option 5 is intersect, and the same process. So first curve, move the cursor over to the other intersection point this time. And close to it, so hit enter. Calculator automatically switches to the second curve when it asks you that question, so enter again. Enter for a third time. There's your other x value. So x could either be negative 5.5 or x is 1.5. And I did round it, so if I plug them back into the equation this time, it won't exactly work perfectly, but it'll give us a close approximation. And the only reason it does that is because I rounded it. Okay, so we've just solved it using my calculator. Now you can do this with expressions as well. So even for h, for example, if it looks something like this, well, I can still graph this. So we'll do this one together as well. And I think that's honestly the end, takes us to the end of this video. So we'll do the same thing. So this is going to be y1, and the right side of the equation just make something else, y2. And we can put it in exactly how it looks. So 3x squared minus 6x plus 5. And in the other one, if I just scroll down to y2 and hit the left arrow and go all the way to the end, you'll see the line is actually highlighted, and if I hit enter, I can actually make it a bolded line, which makes it a little bit easier to see. So we'll graph the other one now. So 2x brackets 4 minus x. Close the bracket, press graph. So there's my original one. There's the left side. Here's the bolded one. And again, you can see there's two places where they cross. So we'll go find their intersection points again. So second trace, option number 5. Just make sure your cursor is close to one of the intersection points, and really, you can hit enter just 3 times after that. Great. We've got one of them. So again, I just need the x coordinate for the intersection. So x equals 0.4 is one of them. But there's a second place where it crosses, so we need to do that again. So second trace, option 5. Move the cursor over to that point. Enter, enter, enter. Here's the other one. 2.4 if I round it. Oops. Okay. Just like that, I can find out the solutions very quickly to these quadratic equations. If it's equal to something that's non-zero, intersection is the calculator feature. If it's equal to 0, 0 is the calculator feature that you're going to use. We can do this applications as well, because these really get into like the projectile types of application questions, which are quite common in this course. So on a dive, the diver's height in h meters above the water is given by this equation. The height as a function of time is equal to negative 4.9 t squared plus 3t plus 4, where t is time in seconds after the diver leaves the board. So sketch a graph, state the window settings. So let's graph this first. So let's clear out everything we had, and we'll put in negative 4.9. Now, if I press the button that has my x in it, really that's what I'm going to use here. So I can't really put in a t. The calculator defaults to having x in there. So it really doesn't matter what it says. It'll graph the same way. So negative 4.9x squared plus 3x plus 4. Graph. So here's what it looks like. But notice how in the picture, I don't have the same sort of graph I do on my calculator. There's a lot more that my calculator shows me. So think about this for just a second. If h represents the height above the water, h is our variable for y. Now, I don't care if they go, how far they go into the water. We really only care about once they hit the surface. So I know that if I hit my window settings, we can change this to really show us what the picture is going to be. So for y minimum, I don't care when they're underwater, so I don't care when y is negative. We're just going to make it 0. So 0 is going to be the lowest height they can reach. So essentially that just cuts off the bottom half of this graph. And I only care about when they hit the surface of the water. Now for x, if x represents time in this scenario, a negative time wouldn't make sense. You can't go backwards. So if I press window again, if I can't go backwards in time, we'll make the minimum for time 0, and you'll see that now it looks a little bit more similar to the situation we have. But again, there's a lot of unused space on this graph, so we're going to cut some more of it off. And you know, if you count the tick marks, she hits the water, or I guess it doesn't say, so the diver hits the water just after the tick mark of 1. So if I make my x maximum, if I just make it 2, it's going to really zoom in for me, and I'm going to see this picture a little bit better. You can leave the height, you can cut off a couple if you want, it makes no big deal. So 1, 2, 3, 4 about is where they start, maybe 5, so let's make our y maximum 6, and you'll see it'll take up a lot more space. Okay, so that looks much better, and it really looks like the picture that we were given. So we can draw a graph of this. So I'll use what I have on my calculator. Looks, you know, something like this. And, you know, we can label this a little bit. So this is time across the bottom. This is height as your y-axis. So I've got a sketch. Like, I don't need numbers or anything. It's just the shape of it. Now, in order to state the window settings, they follow a specific pattern. And for each of them, it goes minimum, maximum, and then scale. So if you take a look at what your calculator says, for x, the minimum we set is 0, then 2, then 1. So this says the minimum value for x is 0, the maximum is 2, and each tick mark is worth 1. If I do that for y, again, our minimum is 0, the maximum is 6, but every tick mark is still worth 1. So there's how I can write my window settings. So back to the graph. Determine the diver's maximum height to the nearest tenth of a meter above the water. So if we're looking for the maximum, we're looking for the highest point that they reach. So I'll designate each part as a color. So second trace to bring up that calculate menu, option number 4 says maximum. So that's what we're going to go find. We've done this before. Now left boundary, put your cursor on the left side of the maximum point. So in other words, the left side of the vertex. Doesn't really matter how far you go, but when you hit enter, you'll see your triangle pop up. Question changes to right bound. So move that cursor to the right side of said vertex. Again, doesn't really matter how far. Enter again. Your vertex will be somewhere in between those triangles, so enter for a third time. And there is your maximum. Now their maximum height isn't x, but their maximum height is y. So the height is y is equal to, I think it says the nearest tenth. So 4.5 meters. So I know that this coordinate is about 4.5, and then in terms of x, this is 0.3. Okay, so I have some numbers that I can add to my sketch just to give us an idea. So part C says, how long to the nearest tenth of a second does it take the diver to reach that maximum height? Well, I know x is time, so I just found the vertex. X is, well, the time is the x coordinate of that vertex. So it takes 0.3 seconds for them to reach the maximum of 4.5 seconds. Okay. At what time to the nearest tenth of a second does the diver reach a height of 2 meters? Well, if I think about this, if that's 4.5 as height, maybe 2 is somewhere about here. And, you know, there is a point where this happens. Now, if their height is going to be 2, we've seen this situation before, my equation is going to be equal to 2, which is like me saying, if I add in another expression to my y equals, what we would have done is, you know, in y2, we're going to graph 2. And when I hit graph, you'll see that line being drawn. And we're going to look for where these two lines intersect with one another. So I'm going to hit second trace. Option number 5 is intersect. Okay, so we're going to intersect with 2. And again, first curve, second curve, guess. So first curve, make sure you're close to your intersection, hit enter. Second curve, make sure you're close to your intersection, hit enter. Enter for a third time. And we're looking for the time value. So you can see how y is 2, that's the height. when x is to the nearest tenth 1.0 seconds, that means that y is 2 meters. So it takes 1 second for the diver to come down enough off the platform to get to a height of 2 meters. Okay? How long to the nearest tenth is the diver in the air for? Now, if I'm looking for where they hit the water, really I'm looking for the bottom, right? The literal last point before y changes to a negative. Because here y is equal to 0, I'm looking for x. So really, I'm looking for a 0. I'm looking for the x value to make this 0. So in my calculator, I can press second trace. Option number 2 is 0. Now left boundary is going to be a little weird here because of how we have the graph. So I just want my x to be on the left side of that x-intercept. So if I leave x where it is right now, where my cursor is, above the y-axis is perfect. You'll see your triangle come up, and move your cursor right, and you'll see that the y value will become negative. So just hit enter, and I've got my 2 triangles popping up. And if I hit enter a third time, you can see y is equal to 0. It's hard to tell because the cursor's in the way, but x is actually equal to 1.3 seconds if I round it. So this total dive takes 1.3 seconds, which makes sense because the point we found in blue was 1 second, so another 0.3 seconds for them to dive into the water. Now the height of the diving board is an interesting question because they have to start somewhere. The diving board is at their initial point I just circled in green. Now that means at that point, that's where x is 0. Now on my calculator, if I hit second trace, option 1 will allow you to put in a value of x. So the value of x is 0 here. So I'm going to hit 0 for x and hit enter. It's going to tell me straight up that y is equal to 4. So this diving board is 4 meters. Right? Before they jump, that's where time is 0. So I can use every feature on my calculator here to answer these questions very, very quickly, but I could also do them by hand. The calculator is just much more helpful. So we'll do the other one on the bottom as well, so you have the explanation for both, but they are basically identical, right? If we've done one of these, we really have done them all. So we can take our equation out. We'll graph our other equation in here. So negative 4x squared plus 48x plus 3. And let's make our window back to normal. So zoom 6, we'll reset this. And here's what I see. That's a problem. Right, I only see where this goes up. So I really have to adjust my window settings here. And I know that where I'm at, negative 10 to 10 isn't good enough. If I press zoom and go all the way down to 0, option 0 says zoom fit. So it will fit the picture as best as possible onto the screen. So it gives you a starting point on what to use. So again, this is a projectile, which it's height above ground, and x is going to be time. So again, I don't want time to be negative, so I'll make it 0. And again, if it's height above ground, I don't care where height's negative, so I'll make that 0 as well. So we'll just see what happens. And you can see just by changing those two things, I almost have a perfect picture. I do want to see where it comes back down though, so my x at 10 isn't enough. Let's just make it 20, and then hit graph again, see what happens. Much better. And I'm going to make my y maximum a little larger. Let's make it 150 just to have a little bit of breathing room at the top. Okay, so there we go. So sketch a graph. So we'll draw this really, really quickly. Okay, so there's generally what the shape looks like. And again, it's time, and it's height, and window settings. So if I hit window, we did x first, and it's going to be 0, 20, and 1. For y, it's going to be 0, 150, and 1. So you can think of your window settings as like your recipe. So if somebody else is trying to make the same graph as you, it's helpful to know the scale and numbers you've used so they can recreate the same graph. Part B says, determine the height of the projectile 3 seconds after the launch. Well, x means time, so we're going to do x is equal to 3, so that's value on our calculator. So if we just take a little bit of a guess here at 1, 2, 3, somewhere over here is where I'm trying to find. So second trace, option 1 is value. We'll put in x as 3. We'll hit enter. So here is our value at 111. So y is 111 meters. Part C says, what is the maximum height reached by the projectile? Maximum is the key word. So second trace, option 4 is maximum. So we'll do the same left bound, right bound. So left bound of the vertex, and then right bound of the vertex. So move your cursor far enough over, enter, enter one more time. And here is our maximum. So maximum height reached by this projectile, which is y. So y is 147 meters. Okay, so that value at the top is 147 meters. After how many seconds did the projectile reach this maximum height? So the x coordinate attached to it is 6. So x equals to 6 seconds. The initial height of that projectile at launch. Well, at launch means time is 0, the initial situation. So second trace, option 1 is value again. So we're going to put in a different value of x, but x is going to be 0. Press enter. The initial height is 3 meters. So it's on like a platform or something, but I don't really know. I just know it's not on ground level. Part F says, at what times does this projectile reach a height of 100 meters? Well, I know that 111 is this green point, so maybe 100 is somewhere down here. But you can see that it happens twice. And again, this is the case where we did intersect. So we're going to put our 100 into y2. So hit y equals, down in y2 we'll put 100, press graph, and you'll see that line come across just like we talked about. So we'll have to do intersect a couple times here. So second trace, option 5 is intersect. Cursor is close to one of them, so we'll do the left one first. The first time where this happens, and again this makes sense because whatever goes up has to come back down. So the same height can be reached at multiple times. So enter, enter, enter. One of the times to the nearest tenth is 2.6 seconds. Or the other one, if I do second trace intersect one more time and move it over, enter, enter, enter. The other time this happens is 9.4 seconds. There are the two places. Last thing we're asked to do is state the domain and the range. So if I think about my graph here, domain is all the x values. Right? So the domain has everything to do with x. So it's the set of x values given the restriction that. And, we found out basically, let's just get rid of that. So we found out that if x is time, the initial time I could have is 0, but the maximum time I could have. Well, I know that it takes 6 seconds to reach the top of that vertex, so it must take 6 seconds to come back down. So I know that the maximum time is 12 seconds. And I could be equal to both those values and any value in between, so x is any real number. But in terms of the range, well, the y this time, again, 0 is ground level. We found the maximum was 147. And other than that, y can be any r in between, right? Y can be any real number in between 0, which is the minimum, and 147, which is the maximum. So I've got my domain and range. We found everything. Every one of these projectile questions is basically the same. At the bottom, you're going to have a summary that basically says what we talked about. So there's two ways to solve this graphically. If it's equal to 0, you're finding the zeros. If it's not equal to 0, we're going to look for where the left and right side intersect with one another. So underneath, you'll find a lot of practice ones. And I'll give you the answers for those other ones that we didn't graph up above, just so you can try them and, see how they go. But in the next video, what I think we will talk about is, how to solve these again by factoring. It is something we've talked about previously, but, we revisit it again because, it's such an important concept in this unit for sure. So again, I hope that helped. Take a look, up in the corner. You'll see the next video link there already. So you can take a look at it. Until next time, take care, and we'll see you back here in the next video.